This is the exam review semester 1 in chemistry for grade 8. We're going to revise the following topics are required for the exam. We have chapter 3 atoms, which includes the structure of the atom, the charges, which are the nuclear charge of the electron, total charge of the atom. We have the mass of the atom, the isotopes, how to draw a circle graph, and how to draw a bar graph. Also, we need to study the electron configuration of the atoms, properties of the periodic table, how to find the row and column of an atom in the periodic table. We should study the notes and application in the copybook. Also practice the 2 chemistry worksheets plus the exam review worksheet. Exercise 1. Determine the electronic configuration in each of the following cases. So we have like 6 or 7 cases. In each case, we should determine the electron configuration. Remember, when it says determine, we should explain in detail. We should explain all the necessary steps. If you have a carbon atom which is found in the second row and in column 14, how can we find its electron configuration? So it has 2 shells, right? What are the 2 shells? K, L. Good. What else, Ella? Okay. Yes, so it has 4 valence electrons. 4 valence electrons, it means are the electrons on the last shell, which is L. So what is the electron configuration, Ella, in this case?
K.
Yes, K2, L4. Very good. Thank you. Okay, Selena, part B, magnesium atom has mass number equal to 24 and 12 neutrons. How can we find the electron configuration? So we should find first the atomic number. Okay. A minus n, so it's 24 minus 12, we get 12. So why do we need to find the atomic number? How this will help us? Okay, to find row column for the atomic number? No. What is the second step? We should find the electron configuration. How can we write the electron configuration now? Yes, K what? Okay, what else? Yes. Okay, very good. So if you add the numbers 2 plus 8 plus 2, we get 12, which is the same as the atomic number, which is the number of electrons. Okay, good. Dana, part C, lithium atom has 1 valence electron. So it has 1 valence electron and 2 shells, which are the energy levels. So how can we write the electron configuration?
It's in row 2.
If you have 2 shells, so it's in row 2. So how it has like K, so 2 shells, it means row 2, and it has K, L energy levels, right? So what about the other part, 1 valence electron? Where should?
Column 1.
It's in column 1. So how should we write the electron configuration? What is the electron configuration?
K2.
Yes.
And L1.
K2, L1. So 1 is the valence electron. This is the valence electron. Good. Hassan, fluorine atom has the following nuclei, which is F, 9, 20. So how can we write the electron configuration?
F equal K.
Yes.
To L7.
L7, very good. So since we have Z equal to the number of electrons, which is equal to the number of protons, so we can use the atomic number, this is Z, we can use the atomic number to write the electron configuration. Ali, see, silicon is found directly below carbon, and we know carbon is in row 2 and column 14. We already know this from part A. So how can we write the electron configuration?
First, the silicon is in row 3.
Good, because it's below it, right? So Good. It will remain in the same column, but it has different row now. You remember we used this technique last time. If this is carbon, it's in row 2, column 14, and we said silicon is directly below it, so silicon will be in row 3 and same column, which is 14. So what is the electron configuration now?
Row 3 has 3 since it's row 3, then we have 3 shells.
Yes.
And it has 4 valence electrons.
So it's KLM, and it has 4 valence electrons. The other shells should be saturated. Good. Hamad, boron has a valence shell L and valence electrons equal to 3. So if the valence shell is L, how many shells it has?
2 shells.
Yes, which are KL, good. And valence electron is 3, so where we put the 3, on K or on L? Where do we put the 3?
2 on K and 1 on L.
If you have 3 valence electrons, where are the valence electrons? On the last energy level, on this, or on this? On L. An oxygen atom has an isotope of electron configuration K2L6. Before we answer, Ella, what do you mean by an isotope?
Same atomic number with different mass number.
Yes. So, if you want to write the electron configuration of another atom, which is an isotope, if this one has K2L6, its isotope should have what too? If they are isotopes. What is the other electron configuration of the other isotope? Yes. You said isotopes have same Z, right? Okay. So 2 with 6, they represent what? Yes, so the atomic number is equal to 8. So the other isotope, if it has the same Z, what should be its electron configuration? Yes? It should be the same, because they have the same Z. If they have the same atomic number, then they should have the same electron configuration. This is what I mean by isotope. Okay, Selena, part A in question 2, calculate the number of neutrons of each atom. So the first one is B, 10, 5. Okay, so it's, yes, equals 5. The other one, yes. Good. So we should calculate the angle of B10 pi. The angle equal percentage times 3.6 equals 80 times 3.6 equal 288. The other one, the same rule we use, angle equal percentage times 3.6. So it's 20 times 3.6, we get 72. So this should look like, we should write the percentage inside, and we write B11, 20% for B10. Okay, part C, write the electron configuration of boron atom. So B or 10, whatever. So what is the electron configuration? Yes. Good. Hassan. Identify the location of boron atom in the periodic table. You need to find the row and column. So row, how much? 2. How did you know? How did you know it's 2? It has Kl and it has 2 shells. It has Kl, which are the shells. So it has 2 shells. Column 3, and we add to it So it becomes 13. Very good. When the valence electrons are more than 2, we add 10 to it. Okay, so it has 3 valence electrons. Remember, when it says identify, we need to explain. So this is how we're explaining. Explaining by writing the explanation for the row and column. Why we found row 2, why we found column 13. Exercise 3, the table below shows some information about chlorine atom, the mass of the atom, total charge of electrons QE, or number of neutrons N. Part A, calculate the mass number. So we have this rule, mass of the atom is equal to the mass number A times 1.67 times 10 to the power minus 27 kilogram. Now, we need to find A, so A is mass over 1.67 times 10 to the power minus 27 kilogram. So it's equal to 58.45 times 10 to the power minus 27 over 1.67 times 10 to the power minus 27. So if we calculate it, becomes 35. Okay, Ali, deduce the nuclear charge Qn
Minus 17.
plus 17 because Qn is opposite to QE, so Qn should be plus 17. It's very important to write plus, positive. Okay. Muhammad Saleh, calculate the atomic number Z. Now, you have A equal 35, you have N equal 18, we need to find Z. What is the rule or formula, Muhammad, which relates Z to A and N? Z equal what?
Z equal A minus N.
Yes, so it's 35 minus 18 equals 17. Very good. Last one. Write the atomic representation nuclide of chlorine atom. What should we write below? 17, which is the atomic number, and above 35, which is the mass number.